Okay, so hi everyone, Senan on this side, and in this video we are going to see how to solve this XOR of queries of a subarray. To solve this, before you go through the question itself, what you need to understand is what is the XOR function. So I would be explaining you what is XOR, but if you have some experience with what is the XOR function in this programming, in terms of programming, you would be good to go. Anyways, so you are given an array ARR of positive integers. You're also given the array queries, where queries of I is left of I and right of. So every element in a query is actually a pair of two integers. For each query I, compute the XOR of elements from left to right, that is array of left XOR array of left plus 1 dot 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 to array of right. Okay, so return an array answer where answer of I is the answer to the ith query. Now, first thing, you can just do a for loop. For every query, you can just perform a for loop inside the array from the index left of I to right of I and take the XOR of every element and take that as a part of your answer. That's the brute force solution, but we are going to improve upon that, right? And we'll see in the solution how we actually do that. In the end, you have to return the array answer, where answer of I is the answer to the ith query. Okay, so look at this test case, and I'll just go over to my notebook to do the explanation. So I have the answer of this problem on the top, so that we can actually verify what if we are going in the right direction or I made a mistake while explaining it. So what you have here is the query 0 to 1, right? From that means let me just index this array. Okay, so 0 to 1, so we need XOR from this element, XOR of these two elements basically. So let's calculate that. So 1 in binary is this, right? So first of all, what is the XOR function? So if you have 1 XOR 1, you'll get 1 you get 0, not 1 XOR 0, you'll get 1, 0 XOR 1, you'll get 1, 0 XOR 0, you'll get 0. So basically, if the bits are same, you get 0. If bits are different, you get 1. So that is the idea. Different bits, answer 1. Different bits, answer 1. Same bits, answer 0. Same bits, answer 0. So we have this 1 and 3. So this is the binary representation of 1. This is the binary representation of. So let's do this. So for this one, we are calculating. So 0 0 0 1 0 0 1 1, and when I calculate XOR, we have this as 0 because these are the same bits. This is 1 because we have different bits, and remaining is 0. So we have our answer as 2. So this is 2 in binary. Okay, so now let us look at the next query, which is going from 1 to 2. So these two elements. So what is 3 in binary? It's 1 1. And what is 4 in binary? 1 0 0. Now let's do the calculation. So you see, these two are different, these two are different, these two are different, these two are same. So the answer to this would be 0 1 1 1. And what is this in binary? This in binary is actually, so this in decimal, this binary number in decimal is actually what is 7. Let me write 7. Now we have is 0 to 3. So that means all of these elements. Okay, so what I could do is basically take the XOR of all these elements and just compute the answer. So we know that the XOR of these two is actually 2, which is 0 0 1 1. And if I take 4 as well, so this would give me, this is 2, not 3. Okay, so this is the XOR of these two as calculated in this case. And then after taking this 0 1 0 0, and then I take the XOR of this would give me, this would be 0 1 1 0. So what is this? This is actually 6. So let me just rewrite this as, this is the value of these three elements. Now I just take 8, so 1 0 0 0, and take the XOR. This is 0, this is 1 1 1. So what is this? This value is what? This value is actually equal to 14, and therefore this value is also 14. So I hope you're able to see that we are actually doing this correctly. So finally we have 3 comma 3, that is the last element. So XOR of this with what? Nothing is to be done here. The answer is directly 8 for this case. Okay, so now we actually did do all the calculation necessary to understand what this question is actually asking, and I show you how we actually find these values, the answer. And now what you could actually do is from left to right do a for loop in this array and take the XOR and take that as a part of it from 1 to 2. So I'm going here and taking the answer, and from this 1 to 2 I'm taking the XOR value and placing the value here. From this 3 I'm again going this and this and then placing the value 14 in the answer. And finally for 3, so I'll take this element and I'll place it. Now something to observe here, or you should know about XOR. Let's say I'll do XOR of 1, XOR 1, XOR 2, XOR 3, XOR 3 is what? Just by looking at the expression without solving anything, can you tell me the answer? And I hope you got it right, which is 2. So if you see the same number even number of times, that is actually 0, right? 1 XOR 1, this XORing with the same element itself would give you 0, right? This is also 0, this is also 0. So any number XOR with 0 is that number itself. So what you're left with is 2, and 2 is your answer. At the same time, it does not matter the order of XORing, this would still be 2, right? The order also does not matter in this case. So 1, 1, so this is 0, this 3 makes 0. So what you're left is with. Now let's say you had some sort of a query like 0 to 2 and then 0 to 3 and then 0 to 2 again multiple times. So when you are asking for a query, it's more or less likely you are accessing a database, right? So maybe these queries were made by different individuals. Even in this case as well, what you're trying to do is every time you're calling for a query, you're actually searching the whole array, right? For every query you're taking big O of n time, every query in the worst case, right? So for this query you traverse the whole list. For let's say this query, or let's say another query 03, you would again travel this whole list. So can we improve the time complexity of querying, right? So querying currently is taking linear time, so we don't want that actually. So what we could do is actually use the concept of prefix sum, and in this case this would be prefix XOR. What we are going to do is we are going to store a list of elements which is actually the XOR of this whole list. So let us make another array known as prefix, and prefix of I will store XOR from 0 to I. Okay, and you'll see how this actually. So let me draw this prefix array. Prefix is actually looking like this. So for a single element, what is the XOR? Like in this case 3, 3, the same element, we got the same value as the element itself. So this first element would be 1, the second element would be what? This XORing of these two elements, which is what we calculated in this case, so which is actually now XORing of the first 3 elements. So 0, this XORing with these 2 would give you 2, and XORing with 4 would give you 6. We did the calculation here, right? Remember, would give you the value 6. Finally, XORing all the elements in this case would actually give you 14, 14. Now you have this prefix array, and can you actually utilize this for your solution for all the queries? And answer to that is actually yes. So if my query is 0, 1, so what is the value on my first index? 2. What's the value on my 0th index? It's 1. And what I'll do is what I'll actually do is not the previous index would not point to this, but a number before that. So I'll take the XOR of this and the element at this position there is no element, so I'll take that as 0. So what you get is the value of 2 itself. Okay, this won't be clear, but later on in the next cases you'll be pretty clear about it. Now we have 1, 2, right? So this is 0, 1, 2, 3. So 1 and 2. So what I'll do is, since 1 is pointing here, so I'll take the element before that, which is this one, and the element at the rightmost index. So I'll take a XOR between 6 and 1. So what is XOR between 6 and 1? So 6 is 0, 1, 1, 0. 1 is 0, 0, 0, 1. And XOR is 0, 1, 1, 1, which is 7. So you got 7. Okay. Now what you could do is, for the next query, we have from 0 to 3. So I'll take this element and I'll take an element behind 0, which is no element. So your answer would be 14. Okay. Now finally 3, 3. So I'll take this third element and XOR it 3 comma 3. So I'll take the rightmost element and take the one element behind the leftmost element. What I'll do is I'll do 14 XOR 6. This is what 14 is 1110. This is 0110. So this would give me 1000. You see, this is actually 8. So that was the whole idea, to use a prefix XOR function to reduce the time complexity of querying to big O of 1. So querying would take big O of 1 time, and for if you have Q queries, you will take big O of Q time to actually calculate the queries. Now let's look at the code of how we are actually going to implement this. So here we are. So you see, first I got the size of the array, and then what I do is I created a array of size n named prefix. The first element itself would be what? It would be the same element itself, right? Same element, right? So from I equal to 1 to I less than n, what I do, prefix of I is array of I element at that index and the prefix till I minus 1, right? So that is how I'm calculating the prefix XOR. After that's done, I'll create an answer array and I'll take query of 0, query of 1. If I is 0, that means the value at prefix of j is our answer. So that is why answer.push back prefix of j. Otherwise, if I is greater than 0, then what I do is answer.push back prefix of j and XORing it with the prefix of I minus 1, one index before the ith or the leftmost index. And in the end, what you do is you just return the answer. So you see, it is accepted as well, and runtime is also good. Let's discuss the time and space complexity. So clearly, prefix of n would take what? Big O of n space, and vector answer would take big O of q space, assuming array is of size n and queries is of size q. So space complexity would be n plus q. So what is the time complexity? So we are going iterating for n elements, right? In this case, for every element we are going through this one, so big O of n. And in this case, we are calculating the space complexity of every query in constant time, so big O of q. In this case, the time complexity would be big O of n plus q. Fine. So time and space both are big O of n plus q. And what makes this a bit more complicated is the fact that you are seeing this vector that you're returning is being passed by value. So whatever answer you're storing, a copy constructor would be called for this answer, and the time would also be taken for this answer vector to copy it into a new vector and then return that value. Okay, so otherwise time and space big O of n plus q. And yep, that was the whole video, and I'll see you in the next one.